Very good morning, students. Today we will complete our network analysis. We will study PERT today. PERT is, as I told you before, Program Evaluation and Review Technique. This technique is basically used in the complex business world by the project planners to determine the total expected time to complete any project. Fine. So PERT is an instrument which is used to calculate total expected time to complete any project. Total expected time is denoted by TC. Fine. This time is a mix of three types of time. First, optimistic time, TO. Pessimistic time denoted by TP. Most likely time denoted by TM. What is optimistic time? Optimistic time is the shortest time to complete any project without any disturbance. Fine. Second, pessimistic time. Pessimistic time is the longest time with all types of delay. Okay? And the last one is the most likely time, is the best estimate time for any project. Means it is the time when projects complete most of the time. So it is also known as best possible estimate of time. What is the formula for TC? That is expected time. Total expected time TC is equals to 1 by 3 square bracket 2 times TM plus 1 by 2 TO plus TP. It is also written as like this: 1 by 6 4 TM plus TO plus TP. This is the best way to learn the formula. Fine. 1 by 6 4 TM plus TO plus TP. Second, you have to calculate the standard error. What is the formula for standard error? It is denoted by this. Standard error is equals to TP minus TO divided by 6. Third, you have to calculate the variance. Variance sigma square is equals to TP minus TO divided by 6 whole to the power 2. This is the square of standard deviation. You all know that the variance is the square of the standard deviation. Next, fourth, you have to calculate the probability of any path being completed within a given time. Z is equals to x minus x bar divided by standard deviation of critical path. What is Z? Z here is standard normal variate. X, what is X? X is the given time. X bar, it is the length of the critical path. And this is the standard deviation of the critical path. In this way, you can calculate all these four values: total expected time, standard deviation or standard error, variance, and the probability. For solving any numerical, you first have to draw the network diagram. In the question, you will be given three types of time: optimistic time, pessimistic time, and most likely time. So first you have to draw the network diagram. After drawing the network diagram, you have to calculate the value of TC by this formula. Then you have to calculate the variance. First you will calculate the standard deviation and then you will square the variance. These values TP, TO, TM, all these are given in the question. After calculating TC and variance, you have to find out the critical path. As I told you previously, what is critical path? Critical path is the longest path. Fine. After finding out the critical path, you have to find out the probability. Probability by this formula, Z is equals to x minus x bar divided by standard deviation of the critical path. In this way, you can solve the problem. After finding out this total expected time TC, whenever you will draw the network diagram, you have to mention that time between the two activities. I'll show you through the diagram. If you make diagram, like this: 1, 2, 3. Then you have 3 types of time: optimistic time, pessimistic time, most likely time. You don't have to write all these 3 time over here. What you will do? You will calculate total expected time and you will write here the TC value. Fine. For every activity you have to calculate the TC value. You will make the table. You have to write down the activity. And in the next column you have to write down the TC values. So for every activity like this, you have to calculate the TC values and you will put these value along the path. Fine. TC1, TC2, TC1, TC2, like this. I think you will be able to solve the numerical very easily. Try to solve a numerical from any book of the operation research. Let me know if you have any problem in calculating expected time. Thank you so much for today.